what do we need to do here? We just need to calculate this df over dt, rate of change of the distance between these two persons. Okay, all right? Yeah. So let's calculate one by one. First we need to do these two partial derivatives, right? Yeah, these two partial derivatives. All right, let us write f function in this way: x squared plus y squared minus 2xy cosine theta to the 1/2. All right. Then partial derivative, partial f over partial x. Chain rule, 1/2 x squared plus y squared minus 2xy cosine theta to the negative 1/2, right? Chain rule. Then the second part, partial derivative of the expression inside the parenthesis. That is 2x partial x. Second term 0, so minus 2y cosine theta. Okay. Let me do some simplification. X minus y cosine theta over root x squared plus y squared minus 2xy cosine theta. Right? Yeah. Right. Similarly, partial f over partial y. We can write, take partial, because here I cancel out too. Okay, yeah. So then it's partial y minus x cosine theta, the same denominator. Now we are ready to do the last step calculation with the given data. X 30 meters, y 20 meters, velocity at a certain point 4 and 3. Yeah. But there is one potential problem. What is this theta? Because theta matters. The value of the theta matters here. Yeah. But if you look at the original question, theta is not given. It's unknown. Yeah. I checked the original question. The theta is not given. Then we cannot get explicit value, numerical value, if we do not have the theta. So here I like to choose a convenient theta, because theta should be given. So here I like to choose theta equals 60 degrees. Because if I choose this special value, cosine of theta equals 1/2. Yeah, so very nice value. Yeah. So let me use this special theta value to do the calculation. All right. Yeah. Last step. df over dt equals x prime t. That's the velocity, right? Velocity VA. Yeah. VA, that is 4. 4 times this part. X minus y. X is 30. Y is 20 times 1/2 cosine theta. All right, yeah. Then, yeah. Then, yeah. Velocity 3 y 20 minus 30 times 1/2 over root of 30 squared plus 20 squared minus 2 times cosine theta equals 1. 2 times 1/2 equals 1. So 30 times 20. All right. Then let's do simplification. 10, 20, 80 plus 15, 5, 15, yeah, over root of, yeah, 20 squared, that's 400, plus 30 squared minus 30 times 20. So we take 30 out. So 10 times 30, that's 300. 700. Here, 700. Yeah. Okay, yeah. So 95 over 10 times root 7. Okay, yeah. Oh, also 19, 2 times root 7. Yeah. Yeah, but here, there is a sign issue. Okay? Yeah, before we complete this question, there is a sign issue. Yeah, so if we go back to the original question, theta here, you know, you can see based on the, because we need to calculate the rate of change, right? Rate of change, the distance between these two persons. Yeah. And the distance is decreasing, right? The distance is decreasing. Yeah. Because x is decreasing, y also decreasing. So when we use the derivative, you know, x decreasing, y decreasing, the derivative, we should use the, you know, negative number, right? Yeah. Decreasing. Yeah. So when we do the calculation, we should use the negative number. Yeah. For example, this 4, we use a negative 4. This 3, we use negative 3. The derivative. Okay? Yeah. You know, representing the direction. Okay? The direction, not increasing direction. It's a decreasing direction. Negative sign tells us what we are doing is along the decreasing direction. So at the end, because the rate should be corresponding to the decreasing direction. So it should be negative 19.7. Okay? Yeah. Decreasing. Rate of change is decreasing, not increasing. Okay? Yeah. So when we do the last step, remember in our typical problem solving, there are 4 steps. 1, 2, 3, 4. 4 steps. The last step, we need to do interpretation. We need to get back to the original environment to interpret our answer. Here, when we do interpretation, we need to fix this sign problem. Increasing, decreasing problem. Yeah. All right, so let me stop right here.